Let's take another quick look at reflections. So when a figure is reflected across a line of reflection, such as the quadrilateral four-sided figure we see here at the right, it appears that it's been flipped over the line L. Okay, however, there's other relationships between the original figure and its image. So not just the fact that it's been flipped or looks like we're looking at a mirror image of itself, but there's also specific characteristics to distances and that line of reflection itself. So let's look at those. First off, the line segment that's connecting each image point. So these are image points, A and A prime. A prime is the image of A. So the line segment that's connecting those two, we could call that line or segment A prime. It is perpendicular, meaning that it forms a right angle with the line of reflection. Okay, that's a very, very, very important characteristic to keep in mind. Okay, the line segment connecting each image point is perpendicular to the line of reflection. Okay, another characteristic, the line of reflection bisects, okay, that's a new geometry term, we're going to say cuts in half the line segment connecting each image. So for example, in the reflection, A to P is the same distance as A prime to P. Now how do we know those distances are the same? Well, in our picture, they're using these two markings. These are called congruence symbols, which we will get into a little bit later. But what these symbols mean is that the length from A to P, so segment AP, is the same as or equal to the length from P to A prime. So our two characteristics, okay? When I reflect an image across a line of reflections, I have two things occur. I have the distance between the image and its new image. That distance is perpendicular, if I draw a line perpendicular to my reflection line. Also, that reflection line cuts the image line in half. Okay, two characteristics, very important to remember.